Good afternoon. Today we are going to conduct our next experiment in the Electrical Machines 2 course. The title of the experiment is Determination of Voltage Regulation of 3-phase alternator by ZPF method, or that is also called Pottier triangle method. Now, in order to perform this particular experiment, this is the circuit diagram to conduct this particular experiment. Now in this case, we have to conduct 3 tests on the alternator, namely open circuit test, short circuit test and ZPF test. Now let us see this circuit diagram. Now in this circuit diagram, first of all we require the prime mover. So this is the prime mover, which is our DC shunt motor. Now in this case we have connected 2 rheostats. One rheostat is connected in the field circuit 750 ohm 1.2 ampere, and second rheostat of 50 ampere 5 ohms is connected in the armature circuit. So this is our DC shunt motor, which is acting as a prime mover. Then as far as excitation system is concerned, in the excitation system we have used 750 ohm 1.2 ampere rheostat as a potential divider, and one ammeter is connected 0 to 1 ampere in the series with this field winding or excitation winding to note down field current IF. Now third important part is the armature winding. Now this armature winding is star connected, and as far as open circuit test is concerned, we will keep the alternator armature terminals open and simply connect one voltmeter of 0 to 300 volts across R phase and neutral. In the open circuit test, the procedure is like, first we will start this DC shunt motor or prime mover with the help of 3-point starter and adjust its speed to rated one, that is 1500 rpm, by adjusting the rheostat in the field and armature circuit. Then we will switch on the DC excitation, and after switching on the DC excitation, this rheostat in the potential divider is gradually varied such that field current is increased gradually from 0 ampere to the 1, and each time the open circuit voltage is noted down. So such 6 to 7 readings are taken. The limited value will be rated voltage. We can take the readings up to rated voltage of 230 volts, okay, or we can take 10% more than that, that is we can go up to 253 volts. So that is about open circuit test. Now in the short circuit test, what we can do, we can short this armature terminals. Now how we can short this armature terminals? So here this inductive load, you forget about this inductive load. So in absence of this inductive load, the armature terminals are shorted through ammeter of 0 to 5 ampere, right? Then again the prime mover or DC shunt motor is switched on with the help of this 3-point starter, adjust its speed to rated 1, 1500 rpm, then switch on this DC excitation, and now adjust this potential divider in such a way that the current drawn by the armature in the short circuit test is the rated one. So only one reading is to be noted corresponding to rated current in the short circuit test, how much field current is needed. So that IF value is noted corresponding to rated current of 4.17 ampere. So that finishes our short circuit test. Now third one, in the ZPF test. Now in the ZPF test, what we can do, here we can connect in the armature circuit a 3-phase star connected inductive load. So this star connected inductive load we can connect across the star connected armature winding of the alternator. Now in this case, the procedure is, once again we can start the DC shunt motor or prime mover with the help of 3-point starter, adjust its speed to rated 1. Now you can switch on this DC excitation, okay. Initially this excitation current is small, very less value, then you gradually increase this excitation current till we are getting here the rated voltage of 230 volt. Remember that initially this load is very high, okay. Then gradually what we can do, we can increase this load. We can increase this load current, which is initially very low. The current initially is very low. then we can gradually increase this load current till we are getting here rated current in the armature circuit. So we want to generate a situation where we can get a rated voltage of 230 volt across the armature with rated current of 4.17 ampere when purely inductive load is connected. At the same time, the speed is to be maintained to rated one, that is 1500 rpm. Under this condition, we have to note down this field current required to get rated voltage of 230 volt and rated current of rated current of 4.17 ampere. How much field current is needed? So that field current just we want to note down. So that is how we can conduct the third test, which is known as ZPF test or Pottier method. Okay, so this way we can proceed. Now regarding the setup, so this is our setup. Now in this setup, we have used two DC supplies. DC supply 1 is used for DC shunt motor and DC supply 2 is used for excitation purpose. Now as per the circuit diagram which we have seen earlier, according to this circuit diagram, the connections are done. Now initially I have done connections for the first test, that is open circuit test. So you can see between R and N, I have connected one voltmeter, and this armature terminals of the alternators are kept open, isn't it? Then as far as this DC shunt motor is concerned, from positive it is coming to L, then from A it is coming to the fixed terminal of this rheostat which is connected in the field circuit, armature circuit. Then from the variable terminal of armature rheostat it is coming to A1. Okay. Then from F it is going to the fixed terminal of the field rheostat, and then from variable of this field rheostat it is coming to F1. Then A2 F2 is shorted, and this common shorted point is going back to negative terminal. So this is how we are completing the connections for the DC shunt motor. Now finally, for the connections for the excitation, we have used this DC supply 2 for the excitation purpose. Positive is connected to the first fixed terminal, negative is connected to the second fixed terminal, and from the variable terminal it is coming to DC ammeter positive in the excitation circuit, and DC ammeter from 1 ampere it is connected, from 1 ampere it is connected to F1, and F2 is going back to negative. So that is how the excitation connections or the rotor field circuit connections are completed. So this is regarding the how we can finish the connections for the open circuit test, that is first test in the ZPF method or Pottier triangle method in order to determine the voltage regulation of alternator. Thank you.